Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Irfan RANI, and today I will be presenting the problem of the thing that I try to solve within the research proposal that I will present today. I'm from class Mathematic 1, and today I will be showing you about the integrating dynamic geometry and volume measurement, which is the study of the research proposal, the title of the research proposal that I study. So let's go. So let's first go about my core concepts, which is the volume measurement, which is the key subject in mathematics and STEM involving skills, liquid capacity, and water displacement. Volume measurement is the chosen title for my research proposal because it's a lot of problems that's happen nowadays in education world. So the first one we're going to go through is the GKVM curriculum, which is the geometry knowledge and volume measurement. A computer-based curriculum using dynamic software, which is, for example, Cadbury 3D, GeoGebra to explore 3D geometry and cube arrays. So this is the platform that the student use because of the easy way to learn the geometry subject when using digital platform, because they can view it in 3D, which can because they can view it in front of their eyes, what how the volume or how the shape is. So the next one is the volume measurement only curriculum, which is a traditional approach focusing on side length and volume formulas using static figures, which is the traditional way that we always learn as a kid, such as which is length times width times height. So let's go to the next slide. So the first thing we're gonna go through is the problem statement, which is a lot of problem that we're facing in the geometry world nowadays is the visualization issue. So, which is the year 5 student find it hard to perceive 3D solid as made up of layer of unit of cubes because of the they cannot imagine, or they have a low imagination skills. They cannot think of the any 3D shapes in a representative way of a cube, because we're gonna calculate it, so we need to represent it in a simple way so we can calculate in a simple way. But students, kids, they don't have a lot of imagination, so they are too hard to imagine a something that is represented something. For example, a small unit of cube represented a big 3D solid. So that's the problem in under structural difficulty. So the next one, the problem that we occur is the counting errors. According to research, pupils frequently count only the visible surface cubes while ignoring the interiors one. For example, in a picture or in a question, they always shown the surface area. For example, like a cube is only shown, like in a page, there's only three surfaces that are only shown of a cube. So what are the three of the surface? Because cube has six surface overall. So the other three, which is being hide at the behind of it, we need, as a student or as a person that read the question, we need to imagine it ourselves. So we got a high imagination skill. They might think cube only consists of three surfaces. The other three is being hide behind. They need to imagine themselves. So the next one we're going to go is spatial coordination. Students struggle to coordinate three linear dimensions within the volume formula, because it is, even though students already how to multiply, but they kind of hard to struggle when multiplying using width, length, height, which is three number, and they need to know what is the difference between width and height, and what's the difference between length and width. So they might sometimes confuse between those three. So the next one we're going to go about problem statement is procedural versus conceptual, which is the formula dependency. Unit calculations and formula applications, length times width times height, are frequently prioritized over conceptual knowledge in traditional courses, because teachers find it easier, and also it's a much simpler way to teach on a whiteboard, and it's only multiplying those three things, which is length times width times height. And students already know how to multiply numbers. The only challenges that the teachers need to face is how to differ between the numbers, or how to recognize what is length, what is width, what is height, how to teach the students about it. So that's the challenge that the teacher only need to face. So the next one is the lack of structure. The relationship between 3D array structures and internal or external volume administration is rarely covered in lessons. This is sometimes rarely touched by teachers. So the problem has a lot of occur nowadays. So it's one of the most thing that kind of making the students a little bit not understand about geometry. So the next one is transfer failure. Although students gain procedural fluency, they are unable to comprehend how capacity and displacement are based on solid volume ideas, because these the subject is very hard, will include displacement. Sometimes they confuse how to calculate the volume of object 3D of solid object solid objects using water displacement or something like that. So the next one we're going to talk about is the research objectives of my research proposal. So the first one is to compare pre-post gains in numerical volume calculation and VC and conceptual understanding for solid volume between geometric knowledge, volume measurement, and volume measurement groups, which is two groups that are using for this thing. And the next objective is to compare gains in capacity and displacement problems after common instruction, which is when I order or when I do a pretest use those two groups, which is the GKVM and the VM groups. We already know, we want to know what is the compare using the two ways or two methods. And the final objective is to characterize difference in students' written and verbal reasoning about volume concepts. This to show what is the how is the final result of the student understanding about after certain training session or lesson or interviews about the geometry subject, and we need to compare what is the final result between those GKVM group and the VM groups. So the next one is we're going to talk about is research question. So the first research question about my research proposal, or the title of my research proposal, is this: the GKVM curriculum lead to higher achievement in solid volume measurement than the volume measurement curriculum? Because we know that the geometry knowledge volume measurement using a better for advanced technology rather than the traditional one. So we already know technology sometimes will giving a very surprising result or surprising outcome. Sometimes maybe making the students become better in understanding something. So the next one question is this: do GKVM students perform better on water capacity and displacement problem after identical capacity instruction? So there's no bias in this research. We using the same instruction and the same instruction or lesson between those two groups. We see the GKVM group, geometric knowledge volume measurement groups, and the volume measurement group. So there's no bias at all. So the final one: how do students' written and verbal explanation reveal different use of conceptual and procedural knowledge? So this is to test what is the mastery of the students between those two groups. What is the outcome after a certain training session, a pre-test and a post-test? So how the students' written and verbal explanation is being analyzed between those GKVM and VM groups. So the next one we're going to talk about is research hypothesis, which is the first hypothesis is this: geometric knowledge volume measurement studies will demonstrate greater proficiency in resolving solid volume issues and a deeper comprehension of volume formula, because they're using a technology way, have using the computer or some a lot of things, and they can do a lot of research on the internet. So when they have a lot of information on their hands, they can do a lot of research and get a far better understanding rather than the volume measurement group, because they're using a traditional way. So the next hypothesis is about: does geometry knowledge volume measurement group will outperform the volume measurement group in capacity and displacement, especially in conceptual understanding items requiring judgment? Because when using the internet, they can know a lot of different knowledge, a lot of different argument about, or a lot of far better knowledge rather than the traditional one. They only know what in the textbook or in the whiteboard or the knowledge in the teacher's head. But when using internet, they know a lot of things because there are a lot of knowledge being given by a lot of people. So using the knowledge, they can do a lot of argument between those about the between in these geometry topics. So the learning view of this research hypothesis is building structure network of mental representation is thought to be the process of learning. So next one, let's go to literature review, which is the challenges and technology. Traditional limits. Traditional instruction neglects in-depth exploration of space filling and the structures. For example, like I said before, because of the traditional way, is only limited to what only the teachers know or what the textbooks provided about the context of geometry of or 3D shape in volume. So the next one is dynamic software benefits. The creation of mental image and 2D, 3D transformation is made easier by programs like GeoGebra and Hotjar. So using a visualization app, they can know how the shape looks rather than just looking at a 2D paper in a textbook while all the teachers drawing the shape on the whiteboard. They can do or create the shape themselves using an app, and they can view how the shape works and how many surfaces, because they can view it 30, 60 degrees, and they can rotate it. And the final one is the success stories. Hardware software raised to the engagement and hence the comprehension of cone volume by 79%. This proof that using technology not also making the learning easier, but it engaged students to learn, because technology is a lot of people very interested in technology nowadays. So that also makes students engage in learning. So the next literature review we're going to talk about is capacity and displacement, which is the advanced concept. Student must understand that an object submerged in water displaces water equal to its own value. So when we put an object in in a place or beaker or some sort of place that contains water, and when we need to fill the water to the top, and when we put something in an object or 3D shape, and there's a water that's spilling out, right? So the water that's spilling out is called the water displacement. And the teacher needs to teach to the students that when the water displaces from its own place or a cup or a bowl like that, it is equals the weight or the water or the measurement of the water is equal to the volume of the 3D shape that's being put in the bowl that contains water that is being displaced with off. So the next one is the interconnectedness. Both solid and liquid volume require an understanding of spatial extent and 3D structuring. And then final one, STEM integration. Engineering based activities like playboards can make this concept more meaningful, because they're using a experiment, they're using volume, they can do this research very well. So the next one I'm going to go is about methodology of my research. So the first one is the design. I'm using quasi-experimental design with non-equivalent groups, and the participant is year 5 students in is urban public primary school, which is in the city, so they can use technology, and so that I can create a group that using technology and non-technology group. And the group assignment, 2 intake classes per school assigned to either to the geometry knowledge volume measurement or volume measurement group, like I said before, when doing at the urban public primary schools, I can use, because they have technology, so I can create this kind of experiment. I can do this experiment because they have technology, so I can create a technology group and non-technology group. So the next one is the control. So I'm using the same teacher instructed both group for the same amount of time, so there's no bias in this research at all, using the same instruction, same teacher, which is the same the way of the teacher's thinking, and the same amount of time, so there's no bias at all. Like, I'm not giving the GKVM group a lot of times rather than and giving the volume measurement groups a lot, which is a minimum of time, or vice versa. So the next one is the implementation phases. Phase one is include a pre-test specific instruction with for the geometric volume measurement or volume measurement group, and a post-test. So a pre-test, which is for before doing a certain station, certain lesson or certain training, so they can so the teachers or the researchers can do a baseline of knowledge of the students that they are being test with, whether it's the geometric knowledge, volume measurement, and volume measurement. And the post-test, which is the test for after the training session has been conducted, so they can do a way to qualify or how to analyze the outcome of the students' understanding. And phase two is the capacity and displacement, comprises interviews, a post-test and pre-test, and shared technology supported teaching for both group. So this what is also the same thing, just a different way of doing research or conducting experiment to the students. So the next one is about instructional treatments. Geometry knowledge volume measurement approach is build cube stacks and connect nets to 3D models using dynamic software, because they have technology, so we can use a simple way using software. They can do a research about it, and they can create the shape using the software that's being already existed in the app store or some sort of place. And the next volume measurement approach focus on naming dimension and formula drills using textbook, example, and static illustration, because they don't have technology, they need to write or draw themselves. And they also do not have the internet, or the information on their hands, which is the end of their fingers, so they cannot do a lot of research, so they only need to depend on the textbook example or only the teacher's knowledge. Like for example, they have a mentor, so they can learn from the mentor, and also doing a static illustration. And the next one is the common phase. Both group use video or dynamics representation for liquid volume, because they still have and for the geometric knowledge volume measurement, they can represent the final result of the understanding about liquid volume using videos, while the volume measurements only need to, maybe they can do a video as well. Maybe that's another part of the research, or they can just write it on a paper, a big paper, mahjong paper, and they can represent it for their own groups. So the next thing about methodology is data collection and analysis. So the first one is I use quasi, of course. So I combine, and also I use mixes, quantitative and qualitative. So a pre and post test measuring NVC procedure and theory perception skills. While the qualitative one-on-one semi-structured interviews exploring students' mental models. So a quantitative is a way to how to evaluate the students' understanding using a certain number, and I can do a statistic, a bar chart, something like that. While qualitative is more focused on how to understand the value or the level of understanding of the students, not like in a quantitative way, but we need to understand how the thinking words, so that we know how they understand, how far they understand about the volume subtopics. And the final one is about analysis. Thematic coding is used for qualitative explanation, whereas UNCOVA is used for quantitative data to account for initial disparities. So I use the different two apps or two ways. So I can do the thematic coding for qualitative and UNCOVA for quantitative, because they have two different purposes. So next we're going to talk about the significance of the study. Empirical evidence give information on how to use dynamic software and geometric knowledge to enhance conceptual understanding. So the mentor or the leader, which is the teachers, can give information how to use dynamic software or geometric knowledge, so the students can know and also to enhance their learning, which in the training session before we doing the process, we need to teach the student how to use the software, or how what is the knowledge about geometry. We can Google it. What is more knowledge about geometry that they don't know about. So the next one is visual enhancement. Show how dynamic tools improves visual representation more than traditional methods. This with, like for example, how can we present shape in using apps or technology like GeoGebra? We can show it in 3D shape, and we can rotate it 360 degrees, while traditional way is only draws on a whiteboard, or maybe using like, maybe we need to buy something or just draw on a whiteboard books and only show into the shape, which is only shown a certain surface. Like example, the cube only shown three surface while it has six surface total, so another three is being hide behind. And the final one is the coherent curriculum supports designing a curriculum that treats volume as a network of related issues. So this is the timeline of my project, which is in short in Gantt chart. The first week I use preparation of lesson materials and assignment set instrument, which is I prepare my lesson to do the research in a certain school. As a teacher, I need to prepare the lesson first. And the week 2, week 3 administration of the pre-test for phase 1. This is where I give the test to the students to know what is the baseline, how far they know about volume topics. And the week 3 until 4 is application of the geometry knowledge, volume measurement, curriculum, cube structuring, and dynamic 3D representation, which is this is where I teach the student of the geometric knowledge and volume measurement groups how to use software, or how to do the representation in 3D shape and to represent it in a data in a slide to the overall people or the volume measurement group, how to show what is the difference between the technological way and the traditional way. All right. So before we ending this one, we're gonna go to the part 2 of the Grand Chart project timeline, which is the week 4 and 5, the post-test administration after the application of the geometric knowledge volume measurement to a geometric knowledge volume measurement group, so they can know how to do the 3D shape in a app like GeoGebra, so they can rotate in 360 degrees, and they can represent it themselves using slide to the other people to show how we can learn the volume subject in an app, or doing the geometry knowledge volume measurement in a very interesting way, and we can represent it, and so it can be learned in a more engaged way. So the week 4 and 5, the post administration, the week 6 and 7, distribution of questionnaire and data analysis of results. So we can do the final, can either prove the hypothesis or trying to neglect it. And the final one is the week 7-8 data analysis continues, followed by the final report writer in week